In this demo, we present DIVAs 4.0, a framework for the development of situated multi-agent simulation systems. DIVAs consists of reusable component libraries for control and visualization of simulations, a message transport service, a data management system, and a microkernel responsible for running large-scale simulations. In addition, DIVAs provides abstract classes for the concrete instantiation of agents and situated open environments. DIVAs also provides domain-specific libraries for rapid development of simulation systems. DIVAs components are 100% Java and based on state-of-the-art enterprise-scale technologies. To create a simulation system with DIVAs, we first build the simulation models. The main packages of the framework include DIVAs Core, which contains the microkernel and abstract classes for the instantiation of agents and the environments. It also contains DIVAs Graphical User Interface, MTS, utilities, and visualization components. DIVAs Abstract Agent consists of an interaction module to handle agent perception and communication, a knowledge module to store the agent's knowledge, a task module for managing the agent's tasks, and a planning and control module which serves as the brain of the agent. For instance, to create a virtual agent, the modeler has to create a concrete class extending from the abstract agent provided by DIVAs and realize the agent abstract modules. In addition, DIVAs provides libraries with concrete agent types that can be instantiated by developers. For example, here we show a vehicle agent extending from the abstract agent. After creating the models, we deploy the application using Maven. This generates executables for the simulator and its control panel. Once the simulation is deployed, we first start the simulator service, and then we use the control panel to control the simulation and start its supporting applications. For instance, here we launch the 3D visualizer. We will use it to build the simulation virtual environment. From the right panel, we search for environment objects in different libraries and use them to create the virtual environment. By selecting among a variety of models such as roads, buildings, traffic lights, and trees, we can easily construct complex environments as a composition of the individual environment objects. We can also edit the environment by scaling, translating, rotating, and deleting environment objects. Once the environment is built, we can use different libraries to populate it with various types of agents. These agents correspond to the instantiation of the concrete models defined by the developer. With DIVAs, we can modify properties of a specific agent, such as velocity and heading, and display these properties at runtime. Also, we can track agents by their IDs, change properties of a group of agents, and visualize attributes such as field of view. By activating the agent camera mode, we can visualize the environment from the agent's perspective. Also, we can manually control agents using the keyboard mode. At runtime, the user of the simulation can trigger a variety of events with visual, audible, and olfactory properties in the environment, and study how agents react to them by combining the percepts acquired through their multiple senses. Using the simulation control GUI, users can concurrently visualize the simulation in 2D and 3D. Next, we show how DIVAs can be used for the simulation of a crowd evacuation scenario. To run this simulation scenario, we load a pre-saved office building environment. We populate the office with a crowd of virtual agents. Here we simulate how agents perceive a bomb triggered by the user on the center of the building. The environment reacts to the event by triggering emergency sirens, which are perceived by virtual agents. The agents use their acquired knowledge to plan for the closest exit. We can observe emergent patterns created by the flow of agents toward the exits of the building. To conclude this demo, DIVAs is a framework for the development of situated multi-agent simulation systems with continuous, non-deterministic, and dynamic environments. Users of the simulation can trigger external events on the environment at runtime. Agents do not have access to global environmental data and perceive their surroundings through perception sensors. Agent properties can be modified at runtime. As more libraries are developed, DIVAs will provide a unique framework for the simulation of a variety of real-world domains. Thank you.